Hey everyone, Geophysicist Stefan Burns here. We have some significant space weather inbound in less than 24 hours, potentially up to 36 hours from now, but very likely in less than 24 hours, we're going to have a combined impact. So we have this coronal hole on the sun, which emits a high-speed stream of solar wind. That is going to sweep by and buffet the Earth in that time frame starting tomorrow, December 3rd, later in the day, universal time, adjust for your own time zone, okay? So we have this coronal hole high-speed stream impact. This is a negative polarity coronal hole. It's been on the sun for a long time. And negative polarity coronal holes typically will incite stronger geomagnetic storms. So the forecast for this already would be a G1 or a G2 geomagnetic storm. The scale rating goes from G1 to G5. 1 is a minor storm, 5 is an extreme storm. The official forecast by NOAA is that we are going to have G1 to G2 conditions with a chance of G3 conditions, 25% isolated. That's what they say right here on the 3rd and the 4th. So we could even have up to G3 conditions. The reason why they are saying that is because we had that huge explosion on the sun December 1st. This was a 1.9 X-class flare in addition to a lot of other things. There's a plasma filament that blasted off, just a big explosion on the sun. Most of that is out going towards Saturn and Neptune, which are about to perform a historic great conjunction, a once in every 35, 37 year cycle. So interesting how that big explosion, one of the biggest of the solar cycle in terms of just the sheer effect of it, is going out towards those planets. But there is a slight Earth-directed component that's going to combine with that coronal hole high-speed stream. That's the forecast. And that is what is pushing up that expected geomagnetic activity from potentially G2 to G3. And I am in agreement and resonance with that forecast put out by NOAA. I think they've done a good job in terms of categorizing the potential of a G3 storm. I don't think we go over G3 for this. This was a fairly minor Earth-directed component, but it does exist. We can look at it here. Check out the shock wave on that explosion. And there's multiple, right? So you see this first one right there. Check out the second one right here that follows up afterwards. You see that one really is going more so even in our direction, but you do get this shock wave also headed out this way from the first one. See, going there, and then you get this follow-up. So it does appear that there is an Earth-directed component to this, which is what I talked about right when this happened back on the 1st of December. A lot of people right from the get-go were saying there's no Earth-directed component, and then more chronograph imagery came in. They're like, oh yeah, actually there is. So it's good to actually be able to look at this stuff and get it the first time, because there was enough chronograph imagery to show that partial halo coronal mass ejection. And it does appear that it is going to sweep by and interact with us with that co-rotating interaction region from that coronal hole. Here we see the space weather model for that. This is by NOAA. This was released on the 1st at 8 a.m. Universal Time. We see that propagate this way. This is the top-down view on the solar system. So this is the sun, there's the Earth. We're looking down on the solar system. This is solar coordinate system east right here. This is going out towards Saturn and Neptune. And you'll notice though, a little bit of enhancement right there with that co-rotating interaction region. That sweeps by, and that's expected to increase the plasma density subtly. And then the plasma velocity will go up. The solar wind velocity will go up because there is already this high-speed stream structure there. Now, all of this is potentially likely to trigger high-magnitude earthquakes here on Earth. We track on this channel what's happening with the Earth energetically. So that means earthquakes, volcanic eruptions, geomagnetic storms, weather, especially like extreme weather. We look at the sun, solar activity, space weather. We look at planetary resonances, alignments and such, even cosmic forces, interstellar objects like 3i Atlas. I bring all that together. So if you like the sound of that, you want to stay appraised as to what's happening here, then make sure you subscribe to the channel. Again, I've been your host, Stefan Burns. So over the years, I've noticed that there is a connection between solar activity and earthquakes. And there are a few different mechanisms. And as with all things, it's not like every single time the connection plays out because, well, earthquakes here on Earth are driven by faults and plate tectonics, and there's a whole bunch of things. That is the primary system. It's solar activity that then tweaks and influences that system, okay? So if the Earth is a car and it's running along and you're gonna have to change lanes every now and then, that's an earthquake, right? The sun may be like all of a sudden some big 18-wheeler zooming by, causing you to have to shift, something like that. So there's already always going to be earthquakes on the planet. There are these earthquake rhythms that exist. And what we see is that certain types of space weather, like from these coronal hole high-speed stream impacts, seem to line up pretty much all the time with high magnitude earthquakes. And so I created a graphic showing this connection for 2025 because 2025 has been an exceptional year as it relates to these coronal holes. You typically see these during solar minimum, and you'll see them up here. 2025 has seen a lot of these coronal holes, and they've been in this equatorial zone, meaning that their high-speed stream will sweep by the Earth. Because if it's up here in the northern hemisphere or down here in the southern hemisphere, which we'll see some examples of soon, that solar wind can go to the north and to the south of our planet and basically miss us. But this being trans-equatorial means that that high-speed stream will hit us, and depending on the polarity, that can cause different energy flows around the planet. You have just the zoomed out basic view that it can trigger a geomagnetic storm, but a northward field polarity triggers really strong Birkeland currents. A southward field polarity pushes the magnetic field in more, so it can get quite complex. This coronal hole has been active for many months now, and in fact, this coronal hole has been linked already with many high magnitude earthquakes, including the magnitude 8.8 megaquake. And there's been some interesting antipodal action between the earthquakes off the coast of Kamchatka, Russia, and also the earthquakes in the Drake Passage. They've been pinging back and forth. They're nearly exact antipodes, and the strongest earthquakes of this year, 2025, have been those pinging back and forth. You get one big one, and then another, and another, and another, like this. The first one was in May for Drake Passage, a magnitude 7.3, I believe, and then you had all the quakes, Kamchatka with the magnitude 8.8 being the biggest, and then it pinged back and forth. So it's been crazy. So let us look at this data that I have for you, because this is pretty wild, and it's really quite striking when you zoom through it slowly and really look at it qualitatively. So I did post this already to my Twitter X account, and you can download that video if you want. I'd recommend you do, to scrub through this yourself like we're going to do here, because that is the best way to really track this, okay? Here we have a graphic showing the sun and solar wind density and our seismic activity level for 2025 up to today, December 2nd. And we see these coronal holes on the sun. The key ones to watch are those that are trans-equatorial, like that big one right there, which resulted in a big burst of earthquake activity right here. Some of them are in the southern hemisphere or the northern hemisphere. Often those ones don't seem to trigger anything because their high-speed streams don't connect to the Earth. So there's a few things that you can really pull out of this if you kind of scrub through this. And this video is linked on my Twitter X account. If you want to download this yourself, you can just pull up a Twitter downloader or whatever and play with this yourself. I recommend you do that because all the data is in here. The main things that we check are with this combined graphic there. You'll see some big trans-equatorial coronal holes. One of them has been active on the sun for a while. That guy right there. And that is the one that's about to hit us. We're going to see it right here. That's it again. And the next rotation, which is about to hit us right here, it is. Okay, so there's a few things to note with this. First off is that you'll see some of the biggest releases of earthquake energy are when the solar wind was consistently and for a long duration under 1 particle per cubic centimeter. Okay, you also see that over here. These are kind of the two biggest zones with that, and you see that we had the most seismicity with this. And this seismicity is logarithmic. So it's a huge amount more energy released from a magnitude 8 than a magnitude 7. So if there is a strong correlation there, you really have to pay attention to that. The second thing that you'll notice is that there's two sections where the solar wind density really didn't drop that low. For example, right here, it basically stayed elevated over 1 the whole time, and also what's happening right now. Now, if we go forward in time on this, okay? So we go forward to here, you'll notice this drop in solar wind density is perfectly aligned with this with this increase in seismic activity right there. You'll see another one right here also perfectly aligned with that. I can scroll forward onto that. Look at that. There's that coronal hole in the geoeffective position, trans-equatorial, mind you. And then if we go forward, we see that other one also as well. So if we have to go back to see that coronal hole. Let's just zoom back a little bit. There is that coronal hole. It went geoeffective, rotated off. We're in that low density solar wind just temporarily, and we get an earthquake. But both of those didn't trigger high magnitude earthquakes. So there is this loading effect too, because then if we go forward and we see this big coronal hole quickly followed up by that one, that's what then results in the biggest burst of seismic activity for the year. That was end of July, early August. Cool. So that's another key thing as well that you can track. So the solar wind density, global seismic activity, and these coronal holes really seem to be linked up. And it's really made clear when you put all the data together in time, like I've done here. I'll put the download link in the video description so you can play with this. So where we are right now is over here, where again, solar wind density has been elevated. We've had some trans-equatorial coronal holes. Check out this guy, right? And then we had this one as well. But they didn't really seem to result in any significant reductions in solar wind density. If you look here, we just don't really see it. So there could be another loading effect in place right now, or maybe this coronal hole that we get, the absolute latest one right here, doesn't really drop the solar wind density that much. But it's more than just that. It's also the fact that we have that coronal mass ejection, very slight impact adding into this, which is likely going to lower the solar wind density even more. And then you have those sunspots, which are going to be charging up the ionosphere. So let's check out our ionosphere to learn a little bit more about that. Here we have an animation for our ionosphere, all right? And what we see is that solar radiation comes in during the day, and the ionosphere expands and it has more charge to it. Then at night it decharges, but it never goes fully away. What is the ionosphere? It's the uppermost part of Earth's atmosphere that has a lot of ions, charged particles. Okay, so these are free electrons, protons, just alpha particles flying around. They are able to generate electric currents because they are charge carriers and they're no longer bound in neutral. So they now flow and move with the electric field. And when you have strong electric currents in the ionosphere, you have strong electric currents in the crust and Earth's surface and even deeper down. So what happens is when you have these big sunspots on the sun like we have right now, let's look at that one more time. And we can go forward here to the very end. When you have these big sunspots on the sun and they're Earth facing, they're releasing a lot of extreme ultraviolet and X-ray radiation, which charges up the ionosphere, creating a stronger flow of energy in between the ionosphere and the Earth. The atmospheric gradient goes up, and some of the dynamics of the Earth are electrical in nature. Actually, the Earth is very electrical. People have probably seen, I'm sure, those videos of earthquake lightning going up. It's absolutely insane. So we have these factors that are very important, and the electromagnetic factors of the Earth are often ignored by the mainstream because they just simply need to catch up. Well, a stronger ionosphere strengthens that electric current, And that allows for circuit closure because you also have really strong electric currents underneath. And when you have an ability to close a circuit, now you can have energy flow. And if it flows past a fault and that energy, that electricity, let's call it, right? Or it's actually plasma, but that electricity flows past a fault where the molecular structures are already very strained because they're under tremendous stress. That can then cause molecular bonds to break, and that can then trigger the rupture. So that's the idea as it relates to how a more charged ionosphere can perhaps cause an earthquake to trigger. The stress is already there because of plate tectonics. That's the main system at play. But then you have this electrical domino effect that then can cause the fault to rupture if it's at that critical stress threshold. Another thing to be mindful as it relates to all of this is also the moon, because the moon creates tides on the planet. It's not just ocean tides, it's also earth tides, vertical displacement of the earth. And as a result of that, that also can cause those faults to then hit their critical stress and then rupture. And as I said earlier, we have a full moon coming up on the 4th of December. So here is our true sky chart for this. And we see the constellations as they are, 13 constellations. The Fucus is there. It does cut through the ecliptic plane. I have this set for the time of the full moon. And we see the moon in opposition there to the sun. And this is for San Diego. So if I go forward, you'll see that the moon then rises. So anyone in California on the West Coast in general, the United States, is going to be in for a treat with a perfect full moon rising over the horizon at its maximum effectively. So definitely go out and look for that. This is also a supermoon. So it will be bigger than a normal moon, be brighter and bigger. And for people in the United States, it's going to be rising right at the perfect time. But that is also another factor lining up with this geomagnetic storm, and a full moon will be in Earth's magnetotail. So that means it's interacting with the plasma and the magnetic field, and that in general seems to increase geomagnetic volatility as well. So we have the ionosphere being extra charged up at this moment in time. That's actually already been happening. I've been talking about how those sunspots are going to be Earth center and direct. But if we look at our X-ray flux, we see here that it's already been quite elevated going back to November 27th. See how it's gone up significantly? So our ionosphere is already charged up. The global electric circuit is already stronger. Here's that 1.9 X-class flare. Then you get that geomagnetic storm from the coronal hole high-speed stream and that slight coronal mass ejection impact. And you get the full moon. And we haven't had a big earthquake now for some time. That is a perfect geostorm. Again, not guaranteed to happen. This is a forecast, but it's a higher possibility, which is why I'm making this video and laying out these points at this moment in time. So those are all the factors combined together. We look at our earthquakes here. You see that we haven't had anything big for the past day. 5.6 in Fiji is the biggest here. Thankfully, our earthquake activity in Japan has died down. That's something that we were tracking. I put out a forecast for there being a potential high magnitude earthquake right in this zone here based off of the anomalous swarming that occurred earlier in November. I did say if that died down and stayed quiet going to the end of November, then that risk goes down as well. Thankfully, that's what has occurred. So that is good. But in general, earthquake activity has been low and something big will eventually strike. And I think there's a much higher likelihood of a high magnitude earthquake, magnitude 7+, striking in the next week or so. So that's the official earthquake forecast. Here we see our earthquakes for the past year. So this is 2025, magnitude 6.5 and greater. You see our last big earthquake there was November 27th with that 6.6 in Indonesia. Then here's the 6.8 Japan. There was also a 6.4 that day. And we see our last big one, greater than magnitude 7, was this one in Drake's Passage on the 10th of October. And that was antipodal to this 7.8 that occurred Kamchatka, because these are antipodal to each other right here. And that was in September. So those are the two main areas that have been active. So that's the first place I would look for something high magnitude occurring, would be either Kamchatka or Drake Passage. But we did have that strange swarm in Japan. Hopefully that story is over, but there's plenty of other spots that could go. But you look here, a lot of earthquakes, and they follow those clear rhythmic trends. So I don't know exactly where it may happen. We hope there isn't a high magnitude earthquake, or that if it does happen, it's somewhere that doesn't really affect people, which is why Drake Passage is so great, because it's not affecting anybody here for there to be a big magnitude 7 or 8. And people really aren't affected here in Kamchatka. There is Petropavlovsk right there, but in general, the damage from that magnitude 8.8 megaquake and the tsunami was fairly minimal. So this is a fairly good location in terms of releasing a lot of Earth energy without it affecting people. Whereas anywhere here in Southeast Asia can be very, very destructive. And of course, there's other places in South America, North America, and 90% of Earth's earthquake activity, I think it's like 80, 90%, is along the Ring of Fire. So I don't have a specific location for you. I would just say that this is the highest likelihood. This is the highest likelihood if there is to be something large. Japan, I would say, is kind of next, because we did have that swarm just in the past month, so it's not that far away, but thankfully I would put that percentage a little bit lower now. And then outside of that, I mean, New Zealand's overdue, but that could be 20 years from now. Also, California is overdue, but that could be 20 years from now. So we simply just don't know. Yeah, and a lot of people are asking about Campi Flegrei. I cover Campi Flegrei, the supervolcano in Italy, when there's notable activity there, like seismic bursts. We haven't had a seismic burst there really since February. That was the last big one. So there's ongoing seismic activity. The seismic activity is accelerating rapidly every single year since 2020, actually even going back to 2005. But in terms of there being a big seismic burst at Campi Flegrei recently, it hasn't happened. It's just kind of like now continuous low-grade seismicity. And so that's an area to watch too very closely. And I'll update you if something significant happens there, because I have been doing that now for about 2 years. When there's a big update at Campi Flegrei, I release a video on it. That's my promise to you. But I don't release nonsense updates on places like Campi Flegrei or Yellowstone when there's no activity. You know, I cover what's happening, and then also if I have an intuition as to something may happen, then I'll also look into that. So that's it for today's video. Thank you all so much for watching. I've been your host, Stefan Burns. This is what we cover on the channel. We cover earthquakes and volcanoes and geomagnetic storms, solar activity, space weather, planetary resonances, cosmic forces, comets, all this stuff. So I bring all that together, present videos almost daily. If you like the sound of that, then please subscribe, smash that like button, help the channel grow. And I guess I should also mention, just to sign off, we have a sale that is currently active on earthevolution.com, which is my website where I sell my wellness products. These are all organic herbal tea blends as well as merchandise. And so if you want to get 5% off going till the end of December 2025, and you're located in the US, this is US only, then you can use the code Thanks Stefan, all one word. That's THANKS STEFAN. You get 5% off your order. Whole bunch of great stuff. These herbal tea blends we make and mix ourselves. They're absolutely fantastic. I really recommend at this moment in time fruit tea, because it helps to improve your immunity. It has elderberry, it has rose hips in there for vitamin C. So a lot of good stuff in fruit tea. It's also super tasty. So if you have a sweet tooth, that's the one to drink to help quell that without reaching for the candy bars. But everything here is great. Spirituality is back in stock. Herb coffee, it's all great stuff. So I know you'll love it. And I'm actually wearing right now the Explore the Cosmos Within t-shirt. As you can see, sacred geometry built into it with artwork on the back, the cosmic pyramid. So thank you all so much for watching. Wishing each and every single one of you well. Please take care of yourselves. Hopefully nothing happens. I wish you the best with this upcoming big energy perturbation with this geostorm. So make sure you do some earthing, grounding, eat well, and stuff of that nature. And I'll see you all very soon. Thanks so much.